Hollywood celebrities are good role models. 2 U.S. adults are selected at random without replacement. So I went to 1,000 people and said, do you think Hollywood celebrities are good role models? 200 people said yes. I picked 2 at random without replacement. Find the probability that both adults think that most Hollywood celebrities are good role models. Okay, so for part A, we are doing 2 adults. So that means we're doing first adult and we're doing the second adult. We are doing probability, which means what makes me happy over total. So for the first one, we want good role models. So how many said good role models?
200.
Out of 1,000. And they said without replacement. So we're not putting that, once I ask you, you're off the list. I can't ask you again. So how many is going to be left to ask? 999. And how many said 199 over 999? Yay? And I think I have the answer so that I don't have to multiply it out. It's going to be 0.040. So 200 people said they were good and 1,000 said they weren't. Now, let's go to part B. We're still asking 2 people. This is person number 1. This is person number 2. But this time they say they are not good role models. Not good role models. So how many people said they're not good role models out of the total? 800 out of the 1,000. So 200 people liked them, the other 800 people don't. And we're still doing without replacement. So what would the next fraction be? 799 over 999. So that answer is going to be 0.640. So if 200 liked them, 800 didn't like them. So these are the ones that liked them out of 1,000. These are the ones that didn't like them out of 1,000. Now, if it said with replacement, this fraction would have been the same. 200 over 1,000, 800 over 1,000, because we're putting that person back in. Cool? All right. Now let's go to C. Find the probability that at least one of the 2 adults think that most celebrities are good role models. All right, this one's a little bit different. We still are dealing with person number 1 and person number 2. At least one of the 2 adults think that celebrities are good role models. So, for the first celebrity, we're either going to say, okay, they think they're good, or they may think they're not good. And here, they may think they're not good, or they could think they're good. So, what probability thinks they're good? Out of? What probability thinks they're not good?
800.
Okay, now, because it is without replacement, what would this be without the replacement?
800 over 999.
For the good, without replacement for the good.
800 over 999.
This is the one that matches with that. Which one matches with this one?
799 over 999. Well, that's not good.
I know that these go together. Let me do it this way. Let me do both of the goods. it said at least one of the two adults think that most celebrities are good role models. So we can either say one's good and one's not good, or one's not good and one's good. So we've got to do a good and we've got to do a bad. So I did the probability of one being good, and then I did the probability of them being bad. And I added them together because I had all these combinations. So I did the 200 and the 199 because it's not replacement. And then I did the 800 and the 799 because it's not replacement. So for this one, it's going to be a little bit longer in my calculator. 200 over 1,000 times 199 over 999 plus 800 over 1,000, 799 over 999. Hold on. Hold on. I did something. I had it right and I wrote it wrong. I take that back. Good and not good. I wrote the wrong numbers. Not good and good. So 200 and then 800 out of 999. 800 over 1,000 and 200 over 999. Okay. When we deal, we have to say, because it said one person good and one person bad, so we had to have a good person and a bad person. So if we choose a good person, then there's going to be 800 bad people. But this goes down because of the replacement, but without replacement. Just like when we did the red and the heart and the club, we chose a heart, but the clubs didn't go down. We chose a good, but the bads didn't go down. But the total number went down. Same thing here. We did the bad first, and then we did the good. So we could have a good person and a bad person, or we could have a bad person and a good person. So we could flip-flop them. It's like having a heads and a tails, or a tails and a heads. But the bottom number went down because we're doing the without replacement. I knew I had a good, bad, and a bad, good. So let me do 200 over 1,000, and then 800 over 999, plus 800 over 1,000, and 200 over 999. That looks much better. Looks much better to me, probably not to you. So this is saying if one is good and other is bad, and this one is saying first is good and the second is bad. And that's only because for this one it said both of them would be good role models. Good, good. And this is both as bad. Bad, bad. This one was trickier because it says at least one is good. So we had to do a good and a bad, and we had to do a bad and a good. Because we didn't know how many were good and how many were bad. That one's why that one was a little bit tricky. Let's look at another one. Hospitals typically require that they have backup generators to provide electricity in the event of a power outage. Assume that emergency backup generators fail 22% of the time. When they are needed, a hospital has 2 backup generators so that power is available if one of them fails during a power outage. Find the probability that both generators fail during a power outage. So, y'all, if electricity goes off for us, we can handle it. But if electricity goes off for a hospital, that people that are on life support, people that are on oxygen, people that are on machines to keep them alive, NICU, babies that need the breathing machines, they have to have the electricity. So they have to have generators to keep their hospital going. They can't go without power, which is why when we had those hurricanes, a lot of the hospitals at Myrtle Beach, Conway, they had to move their hospitals, move their patients away because if their electricity went out and they didn't have generators, they were screwed. So this is saying that generators fail 22% of the time. Find the probability that both generators fail. So we want to know the probability that it fails and the probability that it fails. Probability that it fails and the probability that it fails. Okay, this is event number 1 and this is event number 2. So if we have 2 catastrophes, what is the probability that it's going to fail on both catastrophes? 22 over 100 or 0.22. And what about the second one? Same thing, 22 over 100 or 0.22. So if I come over here, it's going to be 22 over 100, which is the same thing as 0.22. So the answer to to number A is that. So there is a 4.84% chance that the generator will fail twice. So on 2 different occasions, there is almost a 5% chance that it's going to fail 2 times in a row. Okay? Find the probability of having a working generator. How would I do that?
The rest out of 100.
The rest. So, fail plus work is 100%. So if it fails 4.84% of the time, then it's going to work the rest of the time. So we're going to do 100 minus 4.84. So 100 minus 4.84. So it is going to work 95.16% of the time. Now, is that probability high enough for your hospital? Have some people saying yeah, and I have some people saying no. If my baby was in NICU or if my daddy was in the hospital on life support, is 95% of the time worth it for me?
No.
The book says almost a 5% chance both will fail, so if it were me, I may want to add a 3rd generator. So some people say 95% of the time it probably is not going to happen, but with my luck, it may. So the book says you may want to add a 3rd generator. 95% is good, but it's better to be safe than sorry. This is good. There you go. I'd rather have like a 99.9 or 99.5. But add a 3rd generator. Just to be safe. All right. Let's look at another one. Treating dependent events as independent. When sampling without replacement and the sample size is no more than 5% of the size of population, treat the selections as being independent even though they're actually dependent. So, in a study of helicopter usage and patient survival, results were obtained from 47,000 blah blah patients transported by helicopter and 111,000 patients transported by ground. If one of the patients in the study is randomly selected, what is the probability that the subject was transported by helicopter? So we're only picking one. So we're only doing one event. One event, because it's one patient, one event. So we want to know the probability of what makes me happy over total. And we're only doing one event because of one patient. I got my little, what did I do over here, highlighter. One is one event right there. Let me see if I can move it down. No. So if I am doing one event, what I want to know is transported by helicopter. How many are transported by helicopter?
47.
The 47,637 is what makes me happy. Those are the ones that are transported by helicopter. What do you think my total's gonna be?
Transported
The ones in that study. So it's gonna be 47,637 divided by 47,637 divided by 159,511. So in that first one, there's a 29 or 30% chance, 29.9% chance that if you pick one person out of the 159,511, the probability that they were transported by helicopter is about a 30% chance. Now, B says we have 5 subjects, which means we are doing 5 events. Event number 1, event number 2, event number 3, event number 4, event number 5. So we're going to do 5 different probabilities, and we are going to multiply them together. Okay? Now, what are we doing? Transported by helicopter. So what's going to go on the top? The 47,637. 47,637. Now what's going to go on the bottom? 159,511. Now, what is the next one going to be?
Without replacement and minus 1.
Find a different color, green. Without replacement, so this is going to be 47,636, 47,635, 47,634, 47,633. What's going to happen on the bottom? 159,510, 159,509, 159,508, 159,507. So when I go to my calculator, thank goodness we don't have to do this by hand. 47,637 divided by 159,511. 47,636 divided by 159,510. 47,635 divided by 159,509. 47,634 divided by 159,508. 47,633 divided by 159,507. So if I change that to a percent, there is less than 0.5% chance that I would get 5 subjects and they were all transported by helicopter. So if I picked 5 people out in a row, there is less than 1% chance. Now, if I only pick one person out, if I walked into that room and I only picked one person out, there's a 30% chance that they were gone by helicopter. But if I picked 5 people out, there's less than a 0.5% chance that they were all by helicopter. Yay? All right, now, as far as the test goes on this section, because I just finished 4.2, as far as the test on 4.2, just because it was in your notes, just because it's in your homework, does not mean it's on your test. Okay? Let me pull up the 4-2. And let's see. All right, we have, make it smaller. And another easy thing to do, another easy thing to do is when you're doing your homework. Let me write these numbers over here. Okay, it says 21 to 24, number 8, number 11 and 12, number 12, number 5 to 7, number 13 to 16, number 25 to 26, and it says number 9 below. We good? I just wrote everything that was in 4.2, these problems over here. Yay? Okay, the number 9 below is right here. From the frequency table to the right, find the probability that a customer waits less than 7 minutes or more than 20 minutes. Probability is what makes me happy. What makes me happy over total. So how would I get total? Add everything up. So 10, 22, 2, 3, 4, 5, 6, 7, 8, 9, 30, 39, 40, 41, 42, 43. And what makes me happy is if it is less than 7. How many is less than 7? 19 and more than 20. 4. Less than 7 would be those two. More than 20 would be those two. So 19, 20, 21, 22, 23. There's your answer. Yay? Okay, so that takes care of number 9 below. Now, if we look at the ones that I listed over here under 4.2, and I just wrote the numbers off to the side. If I go to the homework, and I go in 4.2 homework, and this will kind of hopefully, you've got 30 questions out there, but this will hopefully kind of ease your fears a little bit. This says section 4.2, number 1. Is number 1 on your test? No. It's in your homework, but it's not on your test. Then if I go, this is for, okay, CQL, that's just a comprehensive thing. 4.2, number 5. Do we need to know that one?
Yeah.
Yes. You need to know 5 through 7. So this one, you will need to know on your test. Does that help? And then if I come over number 6, it says 5 through 7. So the previous problem and this problem are not going to both be on your test, one of those. Okay, 4.2-1.
I had a question about this one.
Okay. Assume that a study of 500 randomly selected airplane routes showed that 482 arrived on time. Select the correct interpretation of the probability of an arriving on time. Okay, now, we want to know the probability, so we want to know what makes me happy over total. So we are doing the probability of arriving late. So if 482 were on time, how do we get the ones that were late?
500 minus subtract
So what is 500 minus 482? 18. So we did the 500 minus the 482 because if these were on time, these are going to be the ones that were late. You with me? And 500 is still my total. So if I go to my calculator and I do 18 over 500, I get 0.036. So that means I can get rid of this answer. Yay? So it's either A, B, or D. Oh, I can get rid of the last answer because the last answer has 2 zeros. So it's either A or B. Okay, and it says, interpret event as significant if it is less than 0.05. 0.05 is like 5 cents. This is 3 cents. So it is less than, so it is significant. So if we hit that and check, we got it right.
Number three.
Who?
Number three.
Okay. All right, so you can kind of go through and you can see like this. Hold on, let me get to another one. Now, 4-2 number 9, that one's not on your homework. Now, some of these dashes, these 4.2 dash 6s, those may be on your test. But the point ones, 4.2, 0.9, those came straight out of your text. So you can look straight on those. These are the reading, okay, the dashes may be on your test, so I would definitely look on those. 4.2.21, that one is gonna be on your test, so that will help you. Okay, which one, 25? All right, we're gonna do this one and we're gonna be done. That 3 randomly selected people all have the same birthday. So we're doing 3 probabilities. We're doing a probability, a probability, and a probability. Have the same birthday. So how many birthdays are there to choose from? 365. And what birthday makes me happy? 1. And we'll multiply together. You with me?
I was trying to do like 7 billion people and then like all these populations.
And that's what happens a lot of time with probability, you overthink it.
Yeah.
Now, also remember, y'all, you can go up to question help. Oh, this one doesn't have it because it's from a different book. Sometimes they have it and sometimes they don't. Yeah. All right, I am done for today. I'll start on 4.2. We need to take this in short burst. We're going to start on 4.3 next time, but I'm done with 4.1 and 4.2. We'll start on 4.3 next time.
Homework is due next Sunday, right? Or this
I haven't decided. We aren't done, so it's not this Sunday. Y'all don't freak out on me. It's not this Sunday. Yeah. And the teacher that's helping me get the notes ready, she said the next paper is. You didn't want to hear that, did you? Now, I'll post the notes probably in the morning or this afternoon. The notes for today.
Oh, okay.
Is that okay?
Yeah.
Yeah, that's
Yeah, I have it.
Okay.